Hi, Miss Zimmer here. You've made it through Chapter 8 and Rational Expressions. Woo, round of applause, round of applause. Okay, so now the celebration is done with that. We're going to move on to radicals. Radicals, that's a radicand, so that's a radical. We're going to use a few terms in there, and I will go over all of those. Luckily, radicals are solved within a couple of steps, 2 or 3 steps, not as long as rational expressions, and no factoring, a little bit of foiling sometimes, but no factoring required here, at least not the type we've been using. So let's begin. First, we need to know what square numbers are, cubes, and even numbers to the 4th power. Some of those are going to come up or fit. So first, let's talk about squares. A square number. 1 squared is a perfect square. 1 squared is 1, but 1 squared is pretty common. So we're going to start with 2 squared. 2 squared is 4, 3 squared 9, 4 squared 16, 5 squared 25, 6 squared 36, 7 squared 49, 8 squared 64, 9 squared 81, 10 squared 100, 11 squared 121, 12 squared 144, 13 squared 169, 14 squared 196, 15 squared 225. You should know all of those. And if you don't, make a list. Keep the list handy. The other one that's really helpful after that is that 25 squared is 625. So sort of like down the list, 625 is a big one. So I'll just put this one here. Boom, boom, boom. Skipping from 15 squared all the way up to 25 squared. You won't see too many more of those that are very common or get used a lot. So we need to know our perfect squares. Second, we need to know a handful of cubes. So 1 cubed is 1. We already know that. But 1 is not a very helpful number when we're simplifying radicals. So we're going to start at 2 cubed, which is 8. 2 times 2 times 2. Okay, just to remind you what a cube is. And then 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. Started to see some crossover a little bit. 64 is in there, up here. And then 6 cubed, you're going to see it, but not too often. 216. And pretty much at that point, those are the most common numbers that we're going to use right now. Now, powers of 4. So 2 to the 4th, 4 to the 4th, 16. 3 to the 4th. Now, obviously, you can just, for anything you're not sure what it is, and you make a list, you can say 3, hit the up arrow button to the 4th power, 81. 4 to the 4th, 256, ... Those are some common numbers that you'll see. Actually, 5 to the 4th is also fairly common, 625. And that's because it's 25 times 25, 5 times 5 times 5 times 5. Yes. Powers of 5. You're like, how many are we going to do? No, that's it. This is it. I promise. So 2 to the 5th power, and see, I always have to remind myself, 32. 3 to the 5th power, 243. 4 to the 5th power, 1024. And it's rare that you're going to see anything this far. 3,125. So these are numbers that if you write down on a sheet and you go, wait, I see this number, oh, that's a cube, that's going to be helpful. Or knowing your perfect squares, you should have those memorized. And then having these written down, going to be a little helpful for what we're going to do coming up. Okay, so let's, hopefully you can put those on a sheet and remember what those are, because we're going to use them going forward. Now, first examples using that, I guess I should give you some vocabulary just in case. If I was going to take the square root of 64, there are actually two square roots. There's 8 and there's negative 8. Like, what? The square root of 64 is just 8. Well, you learned that 8 times 8 is 64, but isn't negative 8 squared 64 too? It is. However, we're going to be talking about finding the principal square root. And this is the principal square root. So that is the most common. However, if you're just asked for a square root, there are two. Okay? All right. Now, what if we were asked for this? So we're just asked for now, square root of 64, principal square root 8. If we're asked for the negative of the square root of 64, then that principal square root is going to be negative 8. The negative does not go away. So keep that in mind for your answers. All right, so let's look at a few perfect squares and find each principal square root. And I'm just double checking as I go along to make sure that it's only asking you for principal square roots. Yes, yes, and yes. Great. Just double checking. So here's a few questions. Square root of 36, principal square root 6. 6 times 6 is 36. Negative square root of 16, negative 4. What if we have this? 9 over 100. Well, you would split that up, the square root of 9 over the square root of 100. And yes, it would be 3 over 10. What is the square root of 0? Does it have a square root? Why, yes, it does. And if you use your calculator, you get 0. The square root of 1 is 1. The square root of 0 is 0. You can even take the square root of a decimal. Now, if you notice that you have a decimal number and it is a perfect square number, if the decimal wasn't there, then it's going to be a perfect square as long as the decimal's in the right place. Can you use your calculator? Yes, you can. Keep in mind on the calculator that we have, you have to hit second and then find the square root button, which is right next to the 7, and then hit 0.64 equals 0.8. So we can use that for square roots, but it certainly is going to slow you down, especially when we use square roots in geometry and we use square roots a great deal in Algebra 2. You'll get a lot of practice in Algebra 2 at this. Okay, so those are super easy. You just hope that your homework will end here, but it doesn't. Okay, next part, cubes. Well, we said 2 cubed, let's just make a quick list. Here's some cubes right over in the corner. 2 cubed is 8. 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and so on. So let's keep some of those in our head. So here's what a cube root looks like. if we want the cube root of 64, we would say, oh, excuse me, cube root of 64. Here, this is 2 cubed, 3 cubed, 4 cubed. So this would be 4, or 4 times 4 times 4. Can you put it in your calculator? Yes, you can. How would you do that? 3 first, then second, and you don't want the square root button. You want the one where the up arrow is, and it gives you like a little X there. 3 little X, radical sign, and then 64 equals, and you'll get 4. You're like, we can use our calculator? Yes, that's perfectly fine. However, eventually you need to memorize these so that you can get these done pretty quickly. Now, what about this? Let's think about it. There's a negative under here. Let's go back for a second. Let's say square root of 16. We know that's 4. The principal square root is 4. What about this? Because we had a negative out front for a moment. We said, oh, if there's a negative out front, that's negative 4. What if it's underneath? Well, let's see what the calculator says. Let's consult our ever-knowing calculator. Negative 16. Domain error. Why? There are no two numbers that multiply to negative 16, not that are alike. And remember, a square root is looking for a number that's the same. So negative 4 times negative 4 will give us 16. It will give us negative 16. So if you have a negative 16, there is no such number. It doesn't exist. However, that's different with cube roots, because 3 numbers that multiply can give you a negative. So the cube root of 27 we know is 3, and negative 3 times negative 3 times negative 3 is negative 27. So you cannot have a negative square root. An even root cannot have a negative, but an odd root can have a negative. So even roots, so when I was doing the square root of 16, guess what? We call it a square root. There's actually a 2 here, it's understood. So it's an even root, odd root. So this would be negative 3. If we did a cube root, again, let's say a fraction, like so, we could split it up. Cube root of 1, cube root of 125 equals 1 over 5, because 5 times 5 times 5 is 125. So that list that we started this lesson with, really handy in identifying those cubes. All right, just want to make sure I didn't skip any terms. By the way, this is your radical sign, and underneath is your radicand. Radicand would be underneath. So this is your radical, right? And that is your radicand, just so that you know. Okay. All right. Next up. By the way, was just checking to make sure I had all my vocabulary. This would be called an index. We don't use it too often. Usually we just say it's a square root, it's a cube root. But if I said, what's the index? Here it would be 3. If I went back to that good old square root of 16, the index would be 2. All right, and can we have 4th roots and 5th roots and 6th roots? We sure can. Welcome to Algebra 2. Well, not yet. All right. Well, we're just introducing it here. We're going to use a few of our roots when we're solving in geometry. And when we're in geometry, I'll definitely be going over this again. And then Mr. Scotty will take you up to that next level in Algebra 2. So let's look at some 4th roots. So Fourth root of 16. Oh, and a fifth root of negative 32. Negative fifth root of 8. Let's try that out. And fourth root of 81. All right, let's be bold. What number times itself 4 times will be 16? 2. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. Or 4 times 4 is 16. And that's 4 twos. If 2 times 2 times 2 is 16 times 2 again, isn't that 32? Can we have a negative? We can, because this is an odd number. So this is negative 2. We're like, I'm going to put it in my calculator. So fifth root, 5, second, radical sign, the one with the up arrow, negative 32 equals, bingo, negative 5. So yes, you can use your calculator. It's not cheating. Now, this is 3, or 3 times 3 is 9. 9 times 3 is 27, and 27 times 3 is 81. All right, I skipped over this one. There's a negative out front, so it's going to be a negative answer. Do we have a fifth root of 8? Well, let's check it out. Fifth root of 8. I didn't put the negative out front because I already know that's there. Equals. Oh, it comes out to a decimal. Does it have a fifth root? It does not. So if you get to a decimal number like so, you don't have an answer. It has no root. In fact, what it'll say the root, the third root, the fourth root, the square root, in this case, the fifth root. It has no real root. So that is possible, okay? Or it's not a real number, okay? All right. You're like, I hate those ones where it's none of the above, but that's all right. There aren't too many of them. Okay, moving on. What if we add some radicals in the mix? Like the square root of z squared, or the square root of 16x to the 16th, or the square root of x to the 6th, or the square root of x to the 4th over 25. Okay, so these are all square roots. So our index is 2. These are all 2. Because this is square root. Well, if we want to find the square root of our variable, we go to the exponent and we divide it by our index. So the answer is going to be z to the second divided by our index of 2, or just z. Because isn't it z times z, z squared? Yes. So here, the square root of 16 is 4, and x to the 16th divided by 2 gives us 4 of x to the 8th. So just take the exponent and divide it. Now, so in this case, x to the 6th divided by 2, x to the 3rd. In this case, x to the 4th divided by 2 over the square root of 25, which is 5. So x squared over 5. Now, are you going to go around writing these fractions? Probably not. Okay, but that's what is happening when you're solving those problems. Okay, so what if we have a third root? Notice I put the index of 2 here, so you have to remember there's a 2 when you're doing a square root of variables. So here are 2/3 roots. Same rules apply. The square root of any variable, you take its exponent and divide by your root. The third root, the index is already given, 3. Well, the cube root of 27 is 3. 3 times 3 times 3 is 27. Y to the 6th divided by 3 gives us 3y to the 2nd. 6 divided by 3. That's your answer. Here, can we have a negative value? Yes, because it's an odd index. So that would be a negative. The cube root of 125 is 5. 5 times 5 is 25, and 5 times 25 is 125. A to the 12th divided by 3. B to the 15th divided by 3 gives us -5. A to the 4th. B to the 5th. There's our answer. So we're just rolling right along. Now, if you are following it all in the notes that I gave you or in the textbook, we are going to skip over some graphs, but I am going to remind you or show you function notation. We did some graphing of squares already. We're going to miss out on graphing a cube for now, but that's okay. It'll come back, I promise. We did some absolute values, some squares, some quadratics. We factored those. We did all those shifts earlier in the year. So if you were looking at those notes or in the book, we're skipping those for now and just factoring, working on these cubes. Want to make sure that I didn't give you a specific other case at the moment. Looks like we're all good. Okay, I'll cover I just want to make sure that I didn't skip anything that I needed to say for your homework before I went on to the functions. Now, functions are used frequently, and here's a function with a radical. You're like, what is that f of x thing? Well, this could be written as y equals the square root of x minus 5. And we could do that good old t-chart, the xy t-chart, and like plug in some numbers and find our y values and graph it and go to town getting some nice pretty graphs. But we're not graphing it for now. But we are recognizing that this y value is just changing into some new language. It is becoming a function. Functions have a lot of rules to them. And I just want to introduce the notation because as you move into your next classes, geometry doesn't use a lot of function notation, but as you move into doing more and more standardized tests, you will see the function notation. And the last thing I want you to do is go, what? What is that? Well, it's like I said, this is just the y value. So what they're going to give you is something like f of 9. All that means is x, solve it for 9. So the square root of 9 minus 5, 9 minus 5 is 4, square root of which is 2. So f of 9 is equal to 2. That's it. Now, if we were going to graph it, this is your x value, 9. This is your y value, 9. Just happen to be the same. If they ask you for f of -2, we would still take that, plug in -2 for x minus 5. F of -2 is not defined because that would be -7. So not a real number. Not real. Now, Here's another function. They don't always use f. Most commonly, they use f and g and h, just like we use x, y, z for algebra quite often. So here's another one. So here's another function, g of x. And that's how we say it, f of x or g of x is equal to a cube root of x plus 3. Well, let's try g of -2 and see if that one's a real number. -2 plus 3. Cube root of 1. That one's pretty super easy. Cube root of 1 is 1. All right, so for your function notation, all you have to do is plug in and evaluate it. And they don't even ask for the answer to be in any specific form. You just give them that number and you're done. So plug it in. Interesting. I was looking through the homework to make sure that I covered everything, and I noticed that some of the language they put Spanish. Interesting. Respuesta, the answer. Respuesta. Okay, just makes it sound really exciting. Okay, so we've done all of the things that we're going to do in section 9.1, and at the end of the lesson, we're going to do something called simplifying radical. And we're going to go back to just square roots. And this is where the fun starts. So let's do our squares again. Square number list. So 2 squared 4, 3 squared 9, 4 squared 16, 25, 36, 49, 64, 81, 100, and so forth. Yes, 11 squared is 121, 169, 196, 225, and so forth. Now, the next section is about simplifying radicals, simplifying. So we're going to write them in a form that is simplified. It doesn't necessarily make it simpler, but it is in a form that we will be able to add and subtract later. It is not a decimal form. So when they use the term simplify, you will not be using this and getting a decimal answer. So let me give you an example of what you will be doing. Well, let's start with the square root of 40. First thing we do when we have a square root is we think about our square number list. Is 40 on it? No, it is not. Are there any numbers on that list that go into 40? Well, yeah. 4 goes in. It goes in 10 times. So we take our square root, 4, we say 40 divided by 4 is 10, and we split this into 2. Now, can you write it under one radical sign? Yes, but it's much more helpful to write it in 2 because this number turns into a 2. This one is not a perfect square, so it stays the same, and that's simplified. It is factoring out or taking out any perfect squares from a number. So now we have the perfect square out of it, and what's remaining is not a perfect square. So let's look at another one. 63. Obviously, once again, 63 is not on this list. That's B. So what we do is say what number that's a perfect square is in 63. Why 9? 9 times 7. Square root of 9 times the square root of 7. Always put the perfect square first. What's left over last? What's the square root of 9? 3. And the radical. So 3 root 7 is how we say it. 2 root 10, 3 root 7. Okay? You could say 2 radical 10 or 3 radical 7. It's just kind of awkward, so we just say root. Okay, meaning square root. Next one, we're still simplifying. I'm just making a little bit more space. All right, how about the square root of 15? And so if you're like, oh, square root of 15, no big deal. That's 3 times 5. Well, 15 is 3 times 5, but is 3 on the number list up here? 5 on the number list? No. So can it be simplified? No. So what do? Well, my math lab might give you the option to put cannot be simplified, but it doesn't always. So what if I've got a blank and it doesn't give me the option cannot be simplified? We write the number again, radical sign, root 15. That is the simplified answer. Now, would I equate that to something that you've simplified before? If you had a problem and you solved it and you got 5 over 10, you would simplify it to a half. And then you would box that, give that to me as your answer. This is a simplified fraction. Well, if I solved a problem and it ended at 1/2, would I just say, well, it can't be simplified, it doesn't have an answer? No. This would be the answer because it's simplified. So root 15 is already in simplified form. Okay, let's roll to a few more of these. Let's do square root of 54. Another number that 9 goes into. 9 goes into it 6 times. Some of you are going, oh, 6 breaks down into 2 times 3. It does, but neither 2 nor 3 are on this list. So we don't care if it factors out. 3 root 6. That's your simplified answer. Next one, the square root of 12. Like, okay, that's 2 times 6. Yeah, but neither 2 nor 6 are here, but 4 is. 2 root 3. Simplified. Next one, 200. Like, I can take 4 out of that. You can. But what happens is you get 50. Can't you take 25 out of 50? Yes. So the problem here is take the highest perfect square out of it and it'll shorten your work. The square root of 100 times the square root of 2 gives you a simplified answer of 10 root 2. Now, I'm not saying you can't take the 4 out first. Excuse me for not putting the radical sign. It is square root of 4 times 50. And it is 2 root 50, but the 50 can be broken down into 25 times 2. So that gives me a 5 here. So what do I do with a 2 and a 5? Multiply. This is all multiplication. And now you've simplified once, twice, and got the same answer. So if you use a smaller instead of a larger perfect square to take out of the figure, you may have to simplify more than one time. All right, what do you do? I'll give you one more example of that, and then I'll give you one more situation. What if you had 48? Some of you are already eyeing that 4. 4 does come out of it. 16 comes out of it 3 times, though. If 4 goes into something, 16 is 4 times 4, so you might want to check. Square root of 16 goes in there 3 times 4 root 3. All right, so last scenario for now. What if we already have a number in front? Well, leave it in front. Break this down. 4 goes into 8. 4 goes into 8 2 times. This turns into a 2. What do I do with the 2 numbers in the front? Well, it's all multiplication. 6 root 2. Just multiply it together. Last one, 5 root 40. It started with a 40 a moment ago. I'll leave the 5 in front. 40 is the square root of 4 times the root 10. 5 times 2, root 10, or 10 root 10. All right, we'll stop there for your homework. I think we got enough for today. Most of them are pretty quick. Once you catch on, it'll go like wildfire. So make sure you keep that square, cube, and possibly fourth and fifth roots in front of you so that you can recognize those numbers. Best of luck, and I will see you for the next radical assignment.